Welcome, everyone. I am just going through a very quick introduction of OLS because that's what I'm here representing. I know most of you might be familiar with it, but some others wouldn't. So I think it's also nice to have some context of who are you speaking with. I would also like to clarify, so today's agenda will cover an introduction to Open Science Essentials, and then we will working on some tooling for project design. I'm sure in some of these aspects, there will be people here that are more experts than me. Again, please feel free to share your knowledge. We are all here learning. OLS, who is OLS? Who we are? We are a non-for-profit organization. What we work is in capacity building, training. We try to diversify leadership. And our motto and our driving force is literally that we believe that to be effective, science should be shared openly with others and also be made freely available. So very in line to what Sam was saying before, for example. We do aim that for our training to help early career researchers, but also other academic potential leaders, or not even academic, just leaders in science in general, to become not just leaders, open leaders, which is the core of this training, but also open science ambassadors. So like the learnings that you take today, you can spread the word around. Again, I guess a lot of people have called me dreamer about this, but I really believe that science can only advance when we share our work with others. Otherwise, there's just no point. And I am aware of the reality. Researchers are usually skeptical about sharing their work because, of course, there's like this fear of getting scooped, or you can also have that inner voice. What if I share my code, my research, and it is wrong? What people are going to think about me? These are valid concerns. I'm not going to dismiss the concerns. What I want is for us to work openly without becoming scientifically vulnerable. So there are things that we can implement in our work, practices that we can implement in our work without those fears that are totally valid that I mentioned before. So the idea is that we are going to explore concepts and practices in open science so that you can start applying them in your work. One big thing that I'm going to highlight in this first session about open science essentials is that there are a lot of practices. Not all of them are applicable to your work, to your life, to science in general. And also, it's not realistic that you are going to use them all in your work. So we can just take it one step at a time. It might cut your eye using open tools, or it might cut your eye to use open data. So just use what you feel might make your science more effective. And why are we here? So we are here because you are SSI fellows. You are the open leaders of the future. And in OLS, we believe that open leaders don't have to be always the loudest people in the room, Open leaders, in our opinion, are the people who designed and who build and empower your projects, and the communities as well associated to those projects to understand, share, and participate, and also improve inclusion. So I'm just going to go through the open science introduction bit. This is very introductory. There's a lot of, I guess from this session, what I would like for you to take home is a bit of reflection. And there are a lot of mentions in the slides, so they will be available for you to then come back to them. Open science is also known as open research, open scholarship. I will be referring as open science, but it can perfectly fit into all these other wordings in here. I want to start by asking you, what is open science for you? If you can drop some, in the chat or in the shared document, that might be better. If you can just let me know what does open science mean to you, and if it's a topic that interests you, if it interests you, why. So I'll just give you a minute for you to share. Yes, thank you, Oscar. Yes, I'm actually going to pull my. There we go. Yes, so this will be activity 0, yeah, from line 69. So what is open science for you? I'm actually just going to take. Perfect. So I liked always to ask this question because even if I've been speaking about open science for years now, there's always things that I keep learning from people and things that I've never thought about or that I forget to mention. And I think it's always nice to share context when we are speaking out these things. So thank you everyone for sharing this. So I can see open science is enabling potential collaboration with others asynchronously, so valid. So being able to extend other work by adapting what's been done before, and potentially for others to do the same with yours. Used open source tools, methods, and data, making your own data tools and methods available to others. Yeah, again, sharing results, methods, and code. What else? Trying to make as much of your work methods outside available. Okay, so I think sharing discovered freely and transparently. Perfect. Yes, this all sounds great. Thank you so much, people. I think a lot of you indeed are focusing on a part of the open science, which is the open data and the open knowledge, which is totally valid. There are some other parts that we will be discussing later. I'm going to go back to basics and just go back to, well, 5 years ago, where the Medical Research Council started to think about research practice and good research practice. Good is a term that we don't really like much. It's very difficult to put a line into good and bad. So we'd like to talk about responsible research. And we do agree that responsible research practice underpins high quality science and supports robust evidence base needed to drive improvements in science. So, of course, one would think that responsible scientists employ responsible research practices. Who is a responsible researcher? One would say like, oh, they strive for excellence, take responsibility, respect the law, research ethics, support. So this is where a lot of you have talked about open science. So they support a culture of transparency, openness, and honesty towards researchers and also the public, maximize public benefit, and continue learning and mentor others. This is a big thing for OLS as well. So this last bit is where we would fit a bit the concept of open science in general. So, of course, we like to always bring this kind of diagram because, of course, responsible science covers a lot of things. So does open science. What we really want to acknowledge, and we'll talk about that later on the part on open data, is that some things cannot and shouldn't be automatically shared. So conservation data, medical records, indigenous data. As much as you want to do open science, you always have to think about what should be open and what shouldn't. And we'll talk about this a bit later. So this is a quote that I always love from Malvika, one of our OLS directors, and is that in the end, openness is about holding the responsibility to be transparent about the decisions that we make around sharing and protecting information as needed. So again, it's not just being open. You might hear me a lot these days that we don't really want to be open by default, which we don't have anything against that, but we really want to be open by design. Why by design? Because if you're design your project to be open, then you have thought about all of these things. You have thought about what you can really share, how are you going to share, how to do it in a responsible way. So these are just a bunch of different definitions about what is open science. again, similar, different in some bits. In the end, I really like, for example, the term movement. So like open science is a movement to make, again, scientific research and dissemination accessible to all levels. Janetta, touching on your project, accessibility is a big thing for us in OLS, and hinder access. I think this is what a lot of people were thinking when replying the prior question. In the end, we tend to follow as well what UNESCO has mentioned about, or has the work that they have done about open science, that in the end is like a set of principles and practices. It's not a law. It's not a, it's not something that is compulsory, but it's a set of principles and practices that make the research accessible to everyone, and its main aim is to benefit scientists and society. Let's not forget about society, because it's who we do the science for. I really want to incide in the mentioning, like, the production of the knowledge itself should be inclusive, equitable, and sustainable. So this is the usual vision of open science. This is an illustration from the Turing Way that I really like. As a researcher, you always think about, oh yes, here is my data, these are the tools that I've used, there's my code, and this is my result. And this is what most of people think about, like, oh yeah, I'll just share all of this, and this is open science, which, to be honest, that's 90% better than a lot of researchers do. Most people just share the data, but they share it without metadata, or they don't share the code and stuff like that. So if you're already sharing these things, you're doing amazingly. I guess what I wanted to bring to you is the different roles of open science. So there are open science, as I've been mentioning, like, can mean a lot of things. And they are all perfectly valid, and you don't have to implement them all. So this, again, I will keep repeating, because one of the problems about open science, and when people start learning about open principles, is that, but this is so much. Like, how am I going to learn about version control and sharing code and sharing a paper and deposit openly and also working with the public and reviewing openly? It's too many things. So let's just choose. I would encourage you to just choose one thing that seems obvious for your work, for your project. Maybe even like too easy to not be doing. So just take one step at a time. And again, this is all like just a bit more tidy up, supported from, so these are the open science elements actually, like, from UNESCO. So it's not a list that we've made up. So this is all in there. And this is something that, again, will benefit science in society in general. So with that, I'm going to then jump a bit more into the concept of open data and FAIR principles. And that is what we're going to go for the rest of the hour. We are going to be discussing a bit about what open data is for you, and have some discussions like why should be using it or why not. So first of all, this slide, when I first designed it, I was like, Sarah, this is very obvious. But then I remembered, Sarah, not everyone, is an RSC or works with the same type of data, or works, that we all work in very different contexts. So I guess I just want to make the point that, again, data, scientific data, is any type of information that is collected, observed, or created in the context of research. It doesn't have to be just numbers. It doesn't have to be code. It's everything that you need to validate or reproduce your research findings, and also what is required to understand and handling of the data. So it could be, of course, primary if it is the raw data that you got in from instruments, or secondary if you've already done some processing, published data, which is the usual format that is available, hopefully for use and reuse, and then the metadata, which is the data about your data. So what is open data? I'm just going to go back and again, keep asking you. I'm going to ask you a lot of questions. I'm sorry. What do you guys think it is open data? You can share loud or not. Again, might seem a bit obvious, but it is not that obvious always. So open data is usually referred, like open science, there are tons of definitions, but it usually all definitions encompass that open data is data that can be freely reused, and redistributed by anyone. Let's keep these three things in mind. Yes, so it has to be freely used, reused, and redistributed by anyone. So these things seem like too easy again, but they have to be done properly because otherwise your data is not really open. So I wanted you to answer, like, why do you think we should use open data? So these were, my three top answers to that question as well. So as you see, you have touched them all already. So why use open data? It does help to make science more reproducible, more accessible. This, of course, especially benefits researchers in the global south or low and middle income countries. There is less weighted grant money. Again, efficiency. Why would you waste that money to collect new data if you can just reuse it? And I will again be a bit annoying about this later, but yeah, it actually can mean that you boost your career, because if you generate data that is citable, people will actually cite it. Good point about this is that you need to use the correct license, but with the correct license, anyone who uses the data can actually cite it. Again, and this is not something new from the academic community in general, or from the scientific community. So in the communities and events, there's always been this vibe of how can you promote, your activities by reusing data? So you can actually improve the user experience. You can create innovation by opening your data, and you can benefit activity providers. So the more data about activities, for example, that is openly available, the more people are likely to find out about those activities and attend them. So a bit similar. So this is, for example, I don't know, I think not everyone here attending collaborations workshop. One of the Hack Days ideas was here by Oscar, thought by Oscar, and is that he wanted a calendar, a calendar with all the events relevant to the SSI community, to the DRTP community. Why do we have to navigate community by community, organization by organization, and see what's going on? Where a lot of things are relevant, and we can have all these things on one calendar. So this is an example about open data. If people allow their own calendars to be public, to then be reused into something else, like Oscar's calendar, that is a good use about open data. So again, we don't need to be thinking about science all the time or research all the time. There are a lot of things to share. Again, this has been also discussed in the public and policy sectors. Sharing open data helps citizens and society to understand why, the workings and the performance of the public sector. In the end, I'm not going to say all of the science, of course, is public funding, but a lot of it, and most of it in Europe, it's public funded. So I think the society has a right to actually decide where the data is coming from, what is happening to it. Again, coming to driving innovation, repeating from the previous slide, better management when we share the data about across different departments, different public sector organizations, there's a better management of it. You cannot manage well if you don't know what's going on. And in general, it just benefits the culture and the environment as well. So this is just a reflection exercise. I want you to have individual reflection exercise. I really like this table. I got it from this webpage in the lower part of the slide. And I would like you to think about how you work, your most recent project. So how many stars would you and your data get if we follow this table? If you make your stuff available on the web, big point, under an open license, you get 1 star. If you make it available as structured data, so using Excel instead of an image scan of a table, and yes, there are people who do this, you get 2 stars. If you make your stuff, your data available in a non-proprietary open format, so using CSV format instead of Excel, you get 3 stars. And this, for example, I've been guilty of doing it for many years. So don't be too harsh judging. If you use URIs to denote things so that people can point on your stuff, you get 4 stars. And 5 stars for whoever links their data to other data to provide context. So if you can just in this minute think about it, wow, Flick is at 4 stars. Amazing, well done, Flick. So how many stars would you get? Things don't have to be, black or white. We can navigate the middle ground. It all depends on project. Sometimes it is not possible to share everything. It is sometimes not feasible. Like in the end, it is extra steps. Those steps will pay off, I think, in the long term. But as we know, academia usually doesn't set projects for the long term, and results in the short term are needed. And at least this is my own experience, but a lot of my open science or open research malpractices were driven by incorrect timelines, to be honest. So, yeah. Okay, so we are going to move on this about what I was just talking about. What are the barriers to open data? So you people are getting between 3 and 5 stars, which I think is amazing. Why do you think you or others are not getting more stars? So why is going on? What is going on that doesn't allow you to go farther in the star movement? So we are going to go back to breakout rooms and discuss for 5 minutes what are the barriers that you've encountered or that you can imagine. Maybe you haven't encountered them, but you have heard of them. So what are the barriers to open data? So some of the barriers, that I came up with, as you can see, you've already mentioned the extra work. I try to have a solution for every barrier because, as I said, I'm a pro-efficiency person. So again, while I acknowledge the extra work, and I was going to say, I suffered that myself, I keep suffering it, and that's why I don't get my 5 stars. But one of the solutions, and that I think is the most efficient one, is when you plan beforehand, when you do this open by design. So if you already start a project by designing it to be open, of course, it does take a bit of time, but once you keep doing it with all your projects, for most of them, you might be able to even reuse what you've set up for the first one. But if you are not able to even reuse specifically, of course, it will take less time the more times you do it. So I would say this is a valid reason, but not a nice excuse to not do it. And of course, we know that there are available tools that you need to that you can reuse and that you can use. Another barrier that I guess, because I think you are, again, more technically experts than me, that I encountered myself, is that there were just too many choices. Which open language to use, which repository to use, which environment to use. When you are learning, again, speaking from a beginning's perspective, when you are learning, there are just too many choices, and you never know what is best or what is worst. So one potential solution is just check what's being used in your specific field, what is already being tested and embraced by your own community, and just go with it. There's, of course, the privacy barrier. As we've said, not all data is meant to be shared, and that's fine. And that's why I haven't put a solution in there. Sometimes data has to be private, and that is okay. And then there's another one that, again, I think it hasn't been mentioned, but this was, or it is still a big thing, at least where I used to do research, which is publication bias. Just negative data doesn't get published or doesn't get published in citable ways. So now that we have repositories like Zenodo or OSF, of course, you can publish that data or bioarchive, of course, if you come from healthcare like me, other archives, there are tons of them. But people are still very shy to actually publish that negative data that will be very valuable for a lot of researchers and that can be citable. So, so I would encourage all of you or a lot of you who are doing research to just like publish what doesn't work. I tried this. I guess in code, in the code field, in the coding field, that's what you share by version controlling. But in other types of research, you can just be as, I tried this, didn't work. That's it. You know, world know what that this didn't work. So you don't have to necessarily repeat it yourself. And again, waste your time, waste your money. Again, coming back to the private data, I just wanted to make the point of that, again, private data doesn't necessarily have to be a barrier for open data. Private data is private data, as it is said, and people do deserve their dignity, their agency over their own data, their privacy rights, and you always have to use ethics and confirmed consent when working with private data. So again, this is the point where I won't be going all shebang saying you have to open all your data, because that is not the case. So let's all be very mindful about this. I will be mentioning this afterwards before shifting to our next and last block, which is FAIR principles. So how many, can I have just an emoji, raise hand, how many of you have heard or even working with FAIR principles? 1, 2, 3, 4. Okay, that's good. I was worried that I was going to bore all of you. Again, so these are going to be very heavy content slides. I'm not going to go through all of them. These are just so you can revisit. I'm just going to mention and summarize a bit. But yeah, as I said, like all this material will be available to you. So that's why they are not my most beautiful slides today. So FAIR principles. I just love this image by the Turing Way. FAIR stands for findable, accessible, interoperable, and reusable. And I'm just going to go by one to hopefully make it a bit clearer. Before I begin defining, I just want to say that like open science, open research definition, FAIR is a set of principles. It's not a rule. It's not a standard. It is a set of principles to define best practices for data and software in general to facilitate, again, what we talk about: discovery, access, reusability by both humans and machines. And I think this distinction is very important when talking about research in the DRTP world and about digital data and things like that. So again, it is not a rule, it is not a standard. It is an evolving process and a vision. Why am I making this distinction? Because things change, as you know. Science change, tools change, and what might work one day might not work the next day. So that doesn't mean that you've done things wrong. That just means that we need to keep evolving. And of course, that's why things are not as easy to implement as we think. So findable. In a nutshell, findable just means that your data has to be or can be discovered by others. So your data, your results can be assigned a global, unique, and persistent identifier. that data are described with rich metadata, and the metadata is clear and explicitly includes the identifier of the data that it describes. Again, on my own experience, coming from doing a lot of genomic analysis, this seems very trivial or obvious or easy. I can assure you it is not how people do it still in 2026. There are a lot of data that is not correctly labeled, that it is misidentified, that are not properly indexed. So, of course, even if it is openly available, it is not reusable. So some current enabling tech, and these are just like very high level. I'm sure there are others. But yeah, so you can just like use digital object identifiers. So it's like a top level mandatory field now in the metadata of each record for data, code, publications. We are talking about people, authors, contributors, you can encourage people to have their own ORCID, which stands for Open Research and Contributor ID. So you can acknowledge the contributions of each person for the research or the data. If we talk about accessibility, again, coming back, so like the data can be made available to others. So findable is that it can be discovered. Accessible is that it can be available. It is not enough that you put it in a repository if it is only your university's repository and someone from outside the university cannot really access it. So it's very important that the protocol is open, it is free, and it's universally implementable. So one of the questions that I'll bring later in the discussion and that I loved to have last time I did this training was, so what about the internet? What about all the repositories, all the data that is out there on a cloud, on an internet repo? That is not really accessible to everyone, is it? So would that be following a fair principle or not? So I'm just going to drop that in there. Or the same about things that are being published and deposited in a library. Is a book that it stands on a library, is that accessible to everyone? So I'll just drop there some questions that we can talk about them later. When we talk about interoperable or interoperability, this I personally find one of the most difficult ones. That means that your data can be integrated with other data. So the data uses a formal, accessible, shared, and applicable language for knowledge representation. It uses a known and standardized data format, uses vocabularies that follow FAIR principles, references to other metadata. So I think technically and personally, this is quite difficult one, also because tools and techniques keep changing. So I think it's more difficult to keep up with these changes or to enable that accessibility at that integration. But again, that it keeps changing is not an excuse to not doing it. I think this is where we can find very useful learnings from I call them data wizards, data stewards, and people doing data management plans and things like that. They are experts in doing these things correctly. So if you have colleagues doing this type of work in your institutions, I do encourage you to reach out and check how to make your data fair. And lastly, reusable. Again, this is a definition quite obvious. The data can be reused by others. In this one, I had an enlightenment some years ago when I was like, but yes, I mean, my data is there, is out there in the internet. It is not enough just to put it out there in the internet. Data is not reusable unless it is released with a clear and accessible data usage language. So we will be talking about some licenses in the next call as well. But I just want to make the point that I will repeat it later. data that is published without a license is not open. That is out there in the internet doesn't mean that everyone can use it. A license, even if it is an open license, is what enables the user to reuse. So whatever you put out there, you've made all the effort on putting it with nice and rich metadata in a nice format, perfectly labeled, in a nice repository. If you don't have a license, that effort is lost because people are not able to reuse something if it's not licensed. So again, some of the tech or the things that we used in our day-to-day. It's one of the repositories that I like is Zenodo, just because it's field or domain agnostic. But if you work in, I think in healthcare and in other fields, the Open Science Framework is also quite useful. Archive, bioRxiv, other kind of archives are very useful that you can keep using it. Flick. Yes, thank you, Flick. So Flick is saying in the chat regarding accessibility, if you have repositories somewhere like GitHub or software spaces, packages, sorry, she recommends adding them to software heritage. So software heritage are doing an amazing work, basically storing what's there in the internet. So it's like a Wayback Machine, but for code. And it is very useful exactly to have a backup plan in case, GitHub stops existing, because it can happen. I mean, who knows? So yes, thank you, Flick, for that. So again, this is me being very annoying about license. And it's not like I'm an expert in licensing, because I am not, but I just want to make you very aware. No license, no access. And it doesn't matter how open you put everything. If there is not a license, there is not, your data is not open. There are different types of licenses. These are just some of them. But yeah, like you have, these are most of the, I think, open ones, BOI. There are like non-commercials that you can share, but it cannot use for commercial purposes. You can have a look. It can be an open license, but you have to state your license. I will keep repeating. Okay, so we're talking about fair data. Is that the same as open data? Not really. They are two different separate things. Both are ideal, but I'd like to make the distinction that closed data actually can be fair, and open data can be not fair. So I think we had here, I'm just going back to the Framapad. Yes, we had here an activity. So when do you think data is not fair? So again, I'm just going to go back to this. So not all the open data is fair. Not all the, and that you have closed data, doesn't mean that is not fair. So you can have closed data that is, for example, searchable in limited access databases, or like only the metadata is available, but it is fair because it needs to be fair for privacy issues. So the fair data motto is, and this is a motto that I really like in general, to be honest, applies to data, applies to community, applies to research in general, is that you aim to be as open as possible, but as closed as necessary. So you have to be very mindful about the data, the community, the tools that you're working with. So I'm just going to give you 5 minutes to think about when data is not fair. Just a quick summary about things, or again, guidelines that I would like to encourage you to embrace as much as you can. So again, deposit your data where others can find it, wherever can that be in your own fields. Make your data and metadata accessible. create metadata again. So this would require that you create metadata, which again, maybe in this crowd is not such a point, but where I came from, it was, yeah, mind-blowing. Include information on ownership and provenance. Dave, coming to your point, don't forget to use a clear license. And I won't repeat enough that data or anything that you share without a license it is not accessible. Describe your data in a standardized fashion using agreed terminology and vocabulary. Sometimes we try to create our own fancy words and acronyms, and that only makes your resources less accessible. Again, share the data and prefer an open file format. That's, I would say, quite an easy one that we can all do. And that, again, speaking personally for myself, I sometimes forget to do. And I promise, the earlier that you start, the easier it gets. But also, it's never too late to start doing these things. So yes, I think that is actually it from me. These are just like a list of resources that I use for these slides. Again, it is all available.